Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is Episode 9, Understanding the Root Causes of Low OEE. Many plant managers know their OEE is too low, but the real question is why? In this episode, we explore how real-time data, smart analytics, and digital twins help uncover the hidden drivers of poor performance, and how fast response can make all the difference. You'll hear how companies are using DBR77 to track every machine cycle, classify downtime, and simulate fixes before implementing them. From reducing micro-stops to cutting changeover time, we'll show you how data turns into action, and how OEE drives profitability. Factory on Air is powered by DBR77, the all-in-one platform for operational diagnostics, production simulation, and smart performance alerts. Let's get into it.
Welcome to The Deep Dive, the show where we take a stack of sources and extract the most important insights, basically giving you a shortcut to being well-informed. Today, we're tackling a challenge that, well, it keeps countless production managers up at night. Consistently low overall equipment effectiveness, or OEE. It's that nagging feeling, right? You know your OEE is too low, but pinpointing the exact why and, crucially, how to fix it quickly can feel like trying to find a persistent leak in a vast, complex piping system without a map. You know there's water on the floor, but you can't quite tell where it's coming from or, how much it's costing you. Our mission today is to pull back the curtain on this very problem. We're going to explore the hidden culprits that drag down OEE. We'll reveal how precise data analysis provides the answers you need, and most importantly, demonstrate how swift, data-driven actions can entirely shift your situation. We're also going to look at how a comprehensive digital transformation platform, DBR77, is specifically designed to support this entire process, turning those crucial insights into real operational efficiency for you. We've got some fantastic material to unpack today, drawing from a detailed analysis of OEE challenges and a comprehensive overview of how cutting-edge technology is solving these very problems in the industrial sector.
It really is a classic industrial pain point. And often the biggest barrier isn't a lack of effort, it's more a fundamental lack of visibility into what's truly happening on the floor. Our sources today really underscore that. They explain how, without granular data, these problems remain kind of abstract, making effective solutions incredibly difficult to implement. It's like trying to stop that leak with a bucket instead of actually finding and patching the pipe itself.
I see. Yeah, that makes sense. So before we even think about patching pipes, maybe we should understand the problems themselves first. What are the common culprits, those usual suspects that consistently drag down OEE in industrial plants? What are we really fighting against when we see that OEE number dip?
That's the perfect place to start, yeah. When we talk about low OEE, we're essentially looking at various forms of lost production time, or maybe lost quality different ways. Your efficiency is basically being drained away. Our sources highlight several key areas that consistently erode efficiency. First off, and perhaps the most glaring one, is unplanned machine downtime. Now, this isn't your scheduled coffee break for the machine or like a planned maintenance period. This is the sudden, unexpected stop, out of the blue. Imagine a critical piece of equipment breaking down due to an unforeseen mechanical failure, or perhaps an unexpected electrical fault, just stops working. It could also be the result of, say, a human operational error. Someone presses the wrong button, maybe, or a part is loaded incorrectly, causing a jam. Happens all the time. Sometimes it's even something as seemingly simple as a lack of necessary raw materials arriving at the right time, leaving the machine starved and idle, just sitting there. These are the sudden, jarring stops that completely derail schedules, lead to bottlenecks further down the line, and honestly, create a ripple effect of chaos through the entire production system. The unplanned aspect is really key here. These are surprises that force an immediate, disruptive halt to production, much more damaging than any planned interruption because they introduce unpredictable variability.
So it's not just the machine being off, it's the chaotic, unpredictable nature of why it's off that multiplies the headache. That randomness, how does that unpredictability mess everything else up?
Well, it creates a domino effect, really. When one machine unexpectedly stops, it impacts upstream processes that feed it and downstream processes that rely on its output. The entire rhythm of the plant is just thrown off completely. And compounding that is another significant drain: long changeover and production preparation times. This refers to all the non-productive time machines spend being reconfigured for a new product or a different batch, or maybe a new task entirely. In many modern manufacturing environments, machines are highly versatile, right? They're designed to produce a variety of items. But that versatility comes at a cost if the setup process is inefficient. It really does. Think about a packaging line that needs to switch from bottling soda to bottling juice, maybe. That requires thorough cleaning, perhaps changing out different size nozzles, relabeling mechanisms, and recalibrating sensors. It all takes time. That time the machine is sitting idle, being adjusted, cleaned, or recalibrated is valuable production time that simply vanishes. Poof, gone. It directly impacts overall throughput and can make small batch production incredibly inefficient, pushing up your unit costs significantly.
That makes perfect sense. Yeah. Time spent not producing is always a concern. Always. But then there's the more insidious issue, maybe. Low machine performance. This one often flies under the radar because the machine isn't actually stopped, right? It's still running.
Precisely. Well, yeah, this is a subtle one. Often less visible than a complete stop and therefore often overlooked. It's easy to miss. It's when machines are running slower than their designed, optimal, or standard cycle times. They're still producing, sure, but at a sluggish pace. Perhaps the motor isn't performing at peak, or there's some friction somewhere in the system, or maybe the tooling is slightly worn. Could be anything. It's like driving a car that's supposed to go 60 miles an hour, but you're only managing 45. You're still moving, yeah, but you're constantly behind schedule. This isn't a breakdown, it's a silent erosion of output that adds up significantly over a shift or a week. The insight here is that this silent killer is often more insidious precisely because it's not a crisis, right? It makes it easier to ignore until the accumulated losses are just staggering. It's the normalization of mediocrity, you could say, that truly drains profitability.
That's a powerful way to put it, the normalization of mediocrity. Wow. It's not glaring breakdown, it's just a constant drag, an invisible leak that constantly drips away your potential.
Exactly. And on the quality side, we have a high defect rate. This means a significant percentage of products fail to meet quality standards. They're just not good enough. These aren't just production losses in terms of output. They represent wasted materials that were purchased, wasted energy used to process them, and often require costly rework or just scrap. If you're producing 100 widgets an hour, let's say, but 10 of them are consistently defective, you're not really getting 100 good widgets, are you? You're effectively only getting 90, but you've incurred the cost of making 100. This hits the bottom line hard, not just from the loss of the product itself, but from the resources already poured into it and the additional resources required to sort, rework, or scrap. That's a double whammy. Then there are micro-stops. These are the tiny, often unrecorded, and seemingly insignificant process interruptions. Think of a momentary jam, a sensor hiccup, maybe a brief pause while an operator adjusts something small. Individually, they might last only a few seconds, maybe a minute. They're so short they often aren't even logged in traditional systems. Or maybe they're manually entered as something vague like operator adjustment without any real detail.
So these are the silent efficiency killers then. Those small pauses that add up to big losses over time. Is that right? It's like 1,000 paper cuts to your productivity, sort of bleeding you dry without a single major wound. What makes them so difficult to detect, let alone address, without the right kind of system in place?
That's a perfect analogy.
Yeah.
Their very brevity and frequency make them incredibly hard to track manually. If a machine stops for 30 seconds every 5 minutes, okay, that's 6 minutes of lost production per hour, which is nearly an hour per shift, just gone. Over a year, that's hundreds of hours, translating to massive production and revenue loss, all from interruptions that no one even bothers to write down because they seem too small. They just become part of the background noise of operations, Expected, almost. Finally, we have more systemic issues. Lack of work standardization and insufficient maintenance procedures. Inconsistent operational methods mean that even if the machine itself is perfect, the human interaction with it isn't uniform. People do things differently. This leads to variability in output, increased errors, and can even contribute to unexpected breakdowns if, say, an operator consistently uses a machine in a way that puts undue stress on it. Or if different shifts perform tasks slightly differently. Imagine 2 shifts running the same line, one with perfectly smooth flow and another plagued by small jams, simply because of minor differences in how operators load materials. It happens. Insufficient preventative maintenance, on the other hand, is like a ticking time bomb. Really is. Skipping scheduled checks, lubrication, or part replacements might save a few dollars in the short term, sure, giving the illusion of efficiency. But it almost guarantees more severe, unplanned downtime in the future, often at the absolute worst possible moment. Murphy's Law, right? These are foundational issues that undermine the entire operational stability and often become the root cause of many of the other losses we just talked about.
Okay, wow. As you listen, do any of these sound strikingly familiar in your own operations or maybe the challenges you've observed? I know for me, just hearing them laid out like that, I can picture exactly where each one might be lurking in a plant, quietly draining efficiency. It's quite sobering.
And what's fascinating here, and really the core message from our sources, is how data transforms these abstract problems into precise, actionable insights. It's truly the diagnostic tool for your production line, helping you pinpoint exactly where that leak is coming from. It stops you from just saying there's water on the floor and actually shows you the cracked pipe. Instead of guessing why OEE is low, data tells you exactly where the most impactful losses are occurring.
That makes so much sense. It's moving from guesswork to evidence. Okay, so we've identified the culprits. Now, how do we actually catch them in the act? What specific types of data are most useful here, and how do we leverage them to pinpoint the exact causes?
Well, the foundation for any meaningful OEE improvement really comes from operational data. It has to. This means meticulously collecting information on machine operating time, all forms of downtimes, whether planned or unplanned, and critically, product quality metrics. This data, when captured effectively and accurately, forms the raw material for analyzing all those sources of losses we just discussed. Without it, honestly, you're flying blind, relying on intuition over hard facts. But it's not enough to just know a machine stopped, right? You need to know why. This is where logging stop causes and errors becomes absolutely paramount. Systematically recording the specific reasons for every stoppage and every error, no matter how brief, enables powerful statistical analysis later on. With this information, you can identify the most frequent and impactful problems. It just jumps out at you from the data. For example, is it always a specific machine that's causing issues? Maybe machine C is responsible for 60% of unplanned stops. Is it consistently happening during a particular shift, perhaps due to a specific operating procedure or team dynamic? Is it always a particular type of material causing jams? Maybe supplier X's material is slightly out of spec. This level of detail moves you beyond anecdotal evidence, oh, I think machine C breaks down a lot, and into concrete, verifiable patterns. It's like getting a detailed forensic report for every single operational hiccup, big or small.
Right, so we're building a crime scene investigation for every lost minute of production, essentially. Drawing a precise map of where the pipe is ruptured and why. I like that analogy.
Exactly. And once you have that detailed log, that forensic report, the next step is trend analysis. This is where you identify patterns over time. Look for recurring themes. You might notice, say, a noticeable increase in micro-stops during certain hours, perhaps at the end of a shift when operators are tired or fatigue sets in, or on specific machines that are maybe due for maintenance soon, or maybe the defect rate spikes every Monday morning due to a weekend shutdown procedure that isn't quite right. Recognizing these trends allows for far more informed decision-making rather than relying on guesswork or just gut feeling. Instead of a general directive to work faster or be more careful, you can target specific machines, specific times, or specific operational procedures. It allows for surgical interventions, not just blanket commands. And crucially, our sources highlight that in conjunction with all this, a digital twin of your processes becomes incredibly powerful, like really powerful. This is where DBR77's capabilities really shine, according to the materials we looked at. A digital twin is essentially a virtual replica, a mathematical model of your real plant, your entire operation, visualized. It's fed by all that operational data we just talked about, the real-time sensor readings, the downtime logs, everything. This allows you to model the effects of these detected problems. So imagine you've identified that a specific machine regularly has a micro-stop due to a tooling issue. Okay. With a digital twin, you can simulate changing out that tooling or adjusting the machine settings or even rerouting product flow around that bottleneck, all without disrupting actual production. You can run what-if scenarios, test potential solutions virtually, and immediately see the simulated impact on OEE, bottlenecks, and overall throughput. This is where DBR77's digital twin technology becomes vital, offering that virtual and mathematical model of the real plant for real-time monitoring, analysis, and optimization. It's a risk-free environment to innovate and solve problems, allowing for what's called stochastic scenario analysis, which basically means it can run thousands of what-if possibilities, factoring in variables and uncertainties like random machine failures or material delays to predict outcomes with remarkable accuracy.
That's incredible. Seriously. So you're not just diagnosing the illness, you're testing treatments in a virtual lab before administering them to the actual patient, preventing any negative side effects or new issues. It's like giving you X-ray vision to see potential ruptures before they even start and a virtual workshop to practice the repairs. That's amazing.
Indeed. It's all about proactive optimization, not just reactive problem solving. That's the shift. It removes a huge amount of uncertainty from implementing changes and allows you to predict where the next leaks might occur so you can reinforce those areas preemptively.
Okay, that raises an important question for you, our listener.
Wow.
Are you truly capturing these granular details in your current system right now? Or are you operating with just a vague sense of where your OEE is hurting? Because the answer to that really impacts what we're about to get into. Because once you do get that precision, the real game changer, according to our sources, is the sheer speed of response. Why is that rapid reaction so critical? Why can't we just, put it on the list and deal with it next week?
Well, the insight here is that the cost of inaction is exponential. It really is. Speed is paramount because problems in a production environment tend to compound very, very quickly. Think of it like this. A small issue, if left unaddressed, often metastasizes into a much larger, more expensive problem down the line. Every minute you delay isn't just a minute lost. It's compounding waste, it's compounded defects, and it's compounded delays downstream. It ripples outwards. The real insight here is that speed is not just efficiency, it's damage control. Active damage control. First, by acting fast, you achieve minimizing production losses. That's the obvious one. If you quickly detect and remove the source of a problem, whether it's a machine malfunction, a material shortage, or a quality deviation, you drastically reduce the amount of lost production time. Every minute that machine is down or running inefficiently is a minute you're not producing saleable goods. It's lost revenue potential. Rapid reaction directly translates to more output for the same invested resources, period. For example, if a machine producing 100 units an hour is down for 30 minutes, you've lost 50 units. Simple math. If you can cut that downtime to just 5 minutes through faster detection and response, you save 40 units. Over a year, that adds up to thousands, maybe tens of thousands of units. It's huge. Secondly, you achieve reduced defect generation. Makes sense, right? If a process starts producing defects, the faster you identify and correct the underlying cause, the fewer defective products are produced. This directly leads to less material waste, less energy waste, and significantly less rework or scrap. All costly activities. It's far, far cheaper to prevent defects at the source than to deal with them after they've already occurred and consumed resources. Imagine a quality issue causing a batch of 500 products to be defective. If you catch that issue in the first 10 products, you save 490 products worth of material, energy, and labor. That's a massive saving. Third, acting swiftly is key for containing impact, limiting the blast radius, so to speak. A swift response means a single failure or issue has a much smaller ripple effect on the entire production process. A localized problem doesn't become a plant-wide bottleneck that shuts everything down. If one machine goes down but you can fix it within minutes, the machines upstream and downstream might only experience a minor pause, a hiccup, rather than a prolonged starvation or backlog. It stops that domino effect before it really gets going, preventing the leak from becoming a flood that damages your entire house, to use your analogy. Fourth, it helps in maintaining production stability. Consistency is king in manufacturing. Keeping a consistent and predictable production pace is absolutely vital for meeting deadlines, managing inventory effectively, and ultimately ensuring customer satisfaction. Erratic production leads to missed commitments, expensive expedited shipping costs, and a general loss of trust with your clients. Nobody wants that. Rapid reaction capabilities allow you to smooth out these bumps and keep the flow consistent, ensuring your promises can be met reliably. And finally, and perhaps most tellingly, our sources emphasize that the reaction time itself becomes a key performance indicator, a KPI in its own right. The time from problem detection to action becomes one of the most critical efficiency indicators for the entire facility. It's a measure of agility. It's not just about what you produce, but how quickly you can recover when things inevitably go awry. Because things will go awry. It signals agility and resilience, and it's a metric top-performing companies absolutely obsess over.
That's such a powerful way to frame it. Yeah. Think of it like catching that small leak in your roof before it turns into a flood damaging your entire house. The faster you react, the less damage and cost you incur. It seems so obvious, but easy to forget. That tiny drip, if ignored, can rot beams, ruin ceilings, and then you've got a major structural problem and a massive bill to match. In manufacturing, that drip is a micro-stop, or a slight slowdown, or a small quality issue. Ignoring it leads to much bigger issues, and the cost compounds rapidly, affecting your entire operation.
Precisely. And the most advanced systems today, like the ones we're discussing, are designed to give you that immediate notification. They act like an early warning system for your entire operation, allowing you to catch that drip the moment it starts, before it becomes a disaster.
Right. And these aren't just theoretical benefits, are they? We've seen powerful transformations in the real world. Let's look at some real-world victories from companies who leverage data to boost their OEE, as highlighted in our sources. These examples really bring the concepts to life and show the tangible impact, I think.
They absolutely do, yeah. These are compelling stories because they demonstrate tangible financial and operational improvements that directly resulted from understanding and acting on OEE data. It's proof positive. One striking example is a home appliance manufacturer. A big name, presumably. This company achieved an impressive 12% improvement in OEE within just 6 months after implementing a machine data analysis system. Think about that. In half a year, they managed to increase their overall equipment effectiveness by more than a tenth. That's significant. This wasn't about buying new equipment or expanding their factory footprint. It was about intelligently using data to optimize the assets they already had, getting more from less. They identified chronic microstops on key assembly lines. They discovered that certain machine settings were consistently suboptimal for specific product types, which they hadn't realized before. And they pinpointed the root causes of their most frequent unplanned downtimes using that detailed logging we talked about. By addressing these data-driven insights, they were able to produce significantly more appliances with the same resources, which is just a massive leap in productivity and profitability.
12% in 6 months is not just incremental. That's a serious jump. That would impact almost any business's bottom line significantly. It really is about unlocking that hidden capacity within what you already have, isn't it?
It truly is, yeah. Another fascinating case comes from an automotive factory. They achieved a significant 8% OEE increase by focusing on one specific, often overlooked area, shortening the average changeover time, just that one thing. They managed to reduce it by just 15 minutes on each shift. Doesn't sound like a lot, does it? Now, 15 minutes might not sound like much in isolation, sure. But consider this. In a high-volume automotive plant, they had perhaps 5-6 major changeovers across multiple lines every single day. By pinpointing exactly where those 15 minutes were lost, maybe it was the tooling setup procedure, or the way materials were staged, or the initial calibration steps, and then streamlining those specific micro steps based on data, those minutes cascaded into hundreds, maybe thousands of hours of additional production capacity annually, just from shaving off 15 minutes per changeover. It wasn't about a grand, expensive overhaul. It was about precision surgery guided by data, fine-tuning.
That's incredible. It really underscores that even seemingly small, consistent improvements, when applied systematically based on data, can create a tidal wave of positive change. Those little inefficiencies really are compounding, both negatively when ignored and positively when addressed.
Absolutely. And then there's the plastics processing plant example. A different industry, same principles. They managed to achieve a 25% reduction in microstops. A full quarter reduction. Remember those pesky brief interruptions we talked about earlier, the silent efficiency killers? This plant tackled them head on. How? By automatically collecting granular data on machine stoppages. That was the key. Previously, these stops were too short to be manually logged effectively, or their causes were vaguely noted, if at all. Operator adjustment again. But with automated data collection, they could suddenly see patterns. Which specific machine experienced microstops most frequently, at what times of day, and in connection with which specific operations or materials? By systematically identifying when, where, and why these microstops occurred, they could implement targeted solutions. Whether it was adjustments to material feed mechanisms, minor machine recalibrations, or specific operator training to avoid certain actions that triggered the stops. Reducing them by a quarter is a profound achievement because it dramatically smooths out the production flow and eliminates a massive amount of previously hidden lost time. It just makes everything run better.
Wow. These aren't just numbers on a report. They represent direct impacts on profitability, reduced waste, and increased capacity. Hard results. Imagine what even a percentage point or two could do for your operations. Or, what a 25% reduction in those tiny nagging interruptions could mean for your overall output. It paints a very clear picture of the power of data and targeted action. It's compelling.
And if we connect this back to the bigger picture, a platform like DBR77 is engineered precisely to tackle these complex OEE issues head-on. That's its purpose. It integrates cutting-edge technologies specifically to do so. It's designed to provide the intelligence needed to not only identify these problems, but also to simulate and implement solutions effectively, essentially turning those abstract leaks into precisely locatable, fixable problems and giving you the tools to fix them fast.
Okay, so how does DBR77 actually go about this? Let's get into the specifics. How does it collect the data, identify these specific loss areas we've discussed, and then leverage its core technologies to turn that data into action and improve OEE?
Right. So DBR77's approach starts with comprehensive data capture. That's the bedrock. The platform meticulously collects data on every single work cycle, every downtime event, planned and unplanned, and every product quality metric. All of it. This is the raw fuel for its analytical engines. But it's not just about collecting data, obviously. It's about making sense of it and turning it into actionable intelligence. That's the value add. The platform then automatically identifies the loss areas. This means it can tell you, for example, the most frequent types of downtime. Is it always a specific type of electrical fault on line 3, or perhaps a consistent issue with material feeding on the packaging machine? Or even a particular type of human error recurring on the night shift? It pinpoints these. It identifies specific machines and processes that generate the greatest losses. It can pinpoint the exact bottleneck machine or the specific stage in a process where OEE is consistently low, showing you exactly where your biggest leaks are. No more guessing. And crucial for proactive management, it identifies patterns of operational behaviors that lead to failures or reduced efficiency. Are certain shifts more prone to micro-stops? Does a particular sequence of operations consistently lead to higher defect rates? The system learns these correlations over time.
So it's not just a dashboard showing numbers. It's an intelligent detective, really, correlating vast amounts of data to find the root causes, almost like tracing the water stains back up the wall to the actual rupture in the pipe.
Exactly. That's a great way to put it. And this leads us directly to DBR77's most powerful feature in this context, according to the source material, predictive simulation with its digital twin. Crucially, with its digital twin capabilities, DBR77 allows for the simulation of corrective actions and their potential effects before they are implemented in the real world. This is huge. It minimizes risk significantly and optimizes the intervention strategy. You can test your repair strategy without shutting down actual production or spending money on a solution that might not work. Let's dive a bit deeper into DBR77's core products based on the documentation and how they directly contribute to OEE improvement. First, advanced IoT solutions. DBR77 utilizes dedicated proprietary systems for data collection. This is key because, as we said, data quality is paramount. Garbage in, garbage out. They install intelligent sensors directly on machines and across entire production facilities. These aren't just basic counters. These sensors monitor critical parameters like temperature, pressure, machine runtime, vibration patterns, even power consumption in real time. This provides the precise real-time data, which is absolutely essential for quick decision-making and for accurately feeding the digital twin and the AI algorithms. It directly addresses the challenge of poor data quality by ensuring consistent, accurate, and real-time input, acting as the eyes and ears of your plant 24/7. Then, the digital twin itself. As we mentioned, it creates that virtual replica of the plant. This isn't just a static 3D model you look at, it's a dynamic, living entity fueled by that real-time IoT data. It faithfully represents production lines, individual machines, material flow, even operator interactions sometimes. It employs advanced algorithms and that stochastic scenario analysis we mentioned to simulate various operational variants. This means you can test practically everything, changing the physical layout of the plant, adjusting new line settings for a different product, simulating the introduction of new robotic arms, you name it. It enables precise bottleneck identification, accurate failure forecasting, predicting when a machine might fail based on its current operating parameters, and the development of optimal operational strategies without disrupting your actual production floor. This virtual environment is where you test your OEE improvement strategies, allowing you to experiment with solutions to your identified leaks in a completely risk-free environment.
So if I think I have a solution, maybe changing a machine speed setting, I can plug it into my digital twin and see if it actually boosts OEE or if it, say, creates another bottleneck downstream without stopping my actual machines. That's incredibly powerful. It's like having a dedicated virtual test bed for all your improvement ideas, a safe sandbox.
Precisely. It's a sandbox for innovation, absolutely, allowing you to iterate on improvements rapidly and without any real-world risk or cost associated with failed experiments. And underpinning all of this is artificial intelligence, AI, and automation. This is where the real intelligence comes in. DBR77's AI systems analyze the vast amounts of data flowing in from the IoT sensors and being generated within the digital twin. This allows them to do a few critical things. They identify inefficiencies that humans might easily miss in the noise. They predict failures before they happen based on subtle pattern changes, and they suggest optimal courses of action in real time. Our sources describe it as functioning like a virtual lean consultant, constantly watching, analyzing, and providing data-driven recommendations in real time. This isn't just about showing you what's wrong, it's about telling you how to fix it, and even predicting the best time to intervene for maximum impact. Furthermore, these systems use machine learning algorithms that continuously evolve and get smarter. They learn based on your plant's historical operational data, and they can even generate synthetic data sets to improve their predictive models further. This means the system gets better and more accurate over time, leading to ever more precise forecasting and process optimization tailored to your specific operation. The system also automatically generates reports and recommendations based on advanced language models and statistical analyses, streamlining decision-making for managers. It's not just raw data reporting, it's providing actionable intelligence, often summarized in plain, easy-to-understand language. We recommend adjusting parameter X on machine Y during the next shift change. And finally, while not directly measuring OEE itself, the marketplace component is indirectly yet crucially important for achieving those quick wins we talked about. The DBR77 Marketplace is an innovative online environment that connects businesses like yours with leading automation technology suppliers and integrators, a curated network. It uses AI for recommendations based on your identified bottleneck. These 3 robotic arms might be suitable, and provides cost-benefit analysis tools. It acts as an intelligent procurement assistant. This significantly shortens the time required for implementing new technologies. Our sources indicate it can cut the average implementation time by half, potentially from an average of 25 months down to around 12. That's huge. And it saves costs too, potentially 30% at the purchase and implementation stage, by facilitating comparisons and negotiations. This is vital for quickly sourcing the right solutions once those OEE problems are identified by the system. You know the problem, you've simulated the best solution in the twin, and now you can quickly find the exact technology and the right partner to implement it, dramatically speeding up your time to ROI.
Okay, so it's a truly holistic ecosystem then. It helps you identify the leak with IoT and AI, simulate the best repair with the digital twin, and then rapidly acquire the tools and expertise to actually make it happen via the marketplace. It really is a full-circle solution for boosting OEE, providing not just diagnosis, but also prescription and delivery mechanism. That's impressive integration.
Exactly. And the OE document we reviewed also highlights the immense benefits of automated alerts. This ties back to that critical speed of response. Imagine getting rapid notifications directly to your phone or workstation about detected anomalies, such as a machine's performance dropping below a predefined threshold, without having to constantly stare at dashboards. Or getting an immediate notification for a sudden increase in defect rates, or if a changeover is taking significantly longer than planned. DBR77 allows you to configure custom alerting thresholds for different roles within the organization. Operators might get alerts about immediate machine issues, shift leaders about performance trends, production managers about critical deviations. This ensures the right person gets the right information at precisely the right time to take action. This significantly decreases the time needed for manual checking of production status, freeing up valuable human resources to focus on actual problem solving and improvement, rather than just data observation and monitoring. It's like having a smart alarm system specifically tailored for your production line, telling you exactly where the new leak has just appeared, sometimes even before it becomes a major issue.
That's a complete game changer, isn't it? I mean, imagine having a system that not only tells you exactly what's wrong, but also intelligently suggests how to fix it, predicts future problems, and helps you find the right solution providers to get it done quickly and cost-effectively. That's the real power of this integrated approach they're describing. Okay, but even with the best intentions of the most advanced tools like DBR77, collecting and analyzing OEE data, implementing these systems, it can present its own set of hurdles, right? It's not always smooth sailing. What are those common challenges that companies typically face when they really try to dive into OEE data analysis? And crucially, how does a platform like DBR77 explicitly address them? Because it's not just about having the cool tech, it's about making it work effectively in the real world where, the pipes actually burst and things get messy.
You're absolutely right. It's easy to talk about the potential of data, but real-world implementation brings significant challenges that can easily derail even the most promising initiatives. It's where the rubber meets the road. Our sources detail these common roadblocks and, critically, how DBR77 seems to be designed specifically to anticipate and overcome them. They understand that adopting new tech isn't just a technical problem, but a human and organizational one, too. First, there's the significant and very common challenge of data quality. We touched on this. Many companies struggle with non-standardized reporting for stoppages and errors. Operators might use different terms for the same issue, or omit crucial details, or simply forget to log short interruptions altogether. This makes the data inconsistent, fragmented, unreliable, and frankly often useless for accurate analysis. It's like trying to diagnose a complex engine problem based on a few scribbled, contradictory notes from different drivers. DBR77 directly tackles this, as we mentioned, by offering its own hardware, including those highly precise sensors, and a robust software system to support automated data collection directly from production lines and workstations. This ensures data is collected consistently and accurately right from the source, eliminating the variability and error inherent in manual logging. Furthermore, it provides a standard database structure that allows for preliminary simulations even when live operational data is initially scarce, providing a useful baseline for problem identification for companies just starting their digital journey. They're not starting from absolute zero.
Right, so it's about providing the tools and the structure to collect good, clean data from the get-go, rather than trying to clean up messy, inconsistent manual inputs later. That makes a lot of sense. Garbage in, garbage out, as they always say.
Exactly. Then there's the complexity of analysis. This is another big one. Companies often have critical data siloed in disparate, unconnected systems. You've got your ERP for planning, your MES for manufacturing execution, maybe various unintegrated IoT devices for some real-time monitoring on specific machines. Combining this fragmented data for a holistic OEE analysis is a huge technical challenge, often requiring manual data exports, complex spreadsheet manipulation, and a lot of time and effort. It's painful. DBR77 operates in a browser-based environment, which dramatically simplifies implementation as it typically doesn't require complex modifications to existing, often rigid legacy IT infrastructure. That lowers the barrier significantly. Its carefully designed API enables seamless, automated integration with common enterprise systems like ERP, MES, or WMS, ensuring all relevant data can be pulled together automatically into one coherent, unified view. And importantly, the sources mention that DBR77's IT support actively assists clients in these integration projects to minimize the time, cost, and hassle involved, reducing the burden on the client's internal IT teams, who are often already stretched thin. Next up, the difficulty in data interpretation. Even if you manage to collect and integrate all the data, making sense of it is another hurdle. Without appropriate visualization tools and clear context, raw operational data can be completely overwhelming, just a sea of numbers, charts, and spreadsheets. It's really hard for anyone, especially busy plant managers or operators on the floor, to quickly abstract actionable insights from that kind of data deluge. Information overload. DBR77's human-centric design philosophy, as they call it, emphasizes simplicity and intuitiveness. The goal is ease of use. They claim most functionalities are accessible and understandable after just a few hours of training, removing the need for users to be data scientists or external IT experts. The platform also offers extensive educational materials like case studies, its own online DBR77 Academy, and regular webinars, making the learning curve very gentle and supporting ongoing user development. Furthermore, the integration of VRR technologies provides realistic, immersive visualizations of simulated solutions, making complex data highly digestible and actionable for everyone from operators on the shop floor to senior management in the boardroom. Seeing is believing, right?
Yeah, so it's not just giving you the raw data, it's translating it into a language everyone can understand and act on immediately, turning complex patterns and diagrams into clear, simple insights. That's crucial for adoption.
Precisely. And that leads directly to the next challenge, the necessity of production team engagement. This is critical for success. Getting teams on the shop floor actively involved in collecting and verifying data where needed, and more importantly, using the data to drive their daily work and decision-making can be a major hurdle if the systems are clunky, complex, or feel like just another administrative burden. Again, that human-centric approach is designed to make the system easy and intuitive to use for all levels of technical proficiency, from seasoned engineers to frontline operators. This encourages adoption and genuine engagement from the shop floor up, without needing specialized IT knowledge. If it's easy to use and people see how it helps them do their jobs better, they will use it, and they will become proactive problem solvers using the insights provided. Another significant challenge, especially for more traditional industries, is the high entry barrier for non-digitalized companies. Traditional enterprises, particularly small and medium-sized ones, SMEs, might not immediately see the real value or even understand the sometimes complex concepts of digital twin and IoT. They might be understandably hesitant to invest significant capital in something that seems abstract or overwhelmingly expensive. DBR77's simplified implementation model and its clear focus on demonstrating a fast ROI directly address this common concern. It prioritizes pilot projects, allowing companies to test the waters and see tangible results quickly on a small scale before committing to a full rollout. It also provides comprehensive educational materials to quickly demystify the concepts and benefits of digital twins and related technologies, allowing companies to gain benefits without significant initial hurdles or massive upfront investments. They aim to make it accessible.
Okay, so they kind of ease you into the deep end of the digital pool rather than just throwing you in head first with a massive capital expenditure request. That makes a lot of sense for organizations that might be hesitant about taking the plunge into digital transformation, less risk.
Indeed. And that ties directly into the issue of long decision cycles in industry. It's a well-known phenomenon. Industrial clients often have lengthy, multi-stage decision processes for adopting new technology, involving numerous approvals, detailed ROI analyses, pilot studies, and layers of bureaucracy. This can significantly delay the implementation of critical improvements. DBR77 specifically focuses on those pilot projects we mentioned, allowing clients to test solutions on a small scale and quickly verify their effectiveness with real data from their own operations. Proof of concept. The subscription-based pricing model also helps by eliminating the need for large upfront capital expenditures, which significantly speeds up internal decision-making processes. It's easier to approve a smaller, recurring operational expense than a massive capital one. If you can try it relatively cheaply and see quick, tangible results, the larger commitment becomes far easier to justify and gain internal consensus for down the line. Then there's the challenge of building and managing a strong integration partner network. This is often underestimated. For digital and automation solutions to work effectively across an entire enterprise, seamless cooperation with a wide range of specialized technology providers, robotics, sensors, software, and system integrators is essential. Managing these relationships and ensuring compatibility can be a logistical nightmare for a single manufacturing company to handle on its own. DBR77's ecosystem includes that integrated marketplace we discussed, connecting manufacturing firms with, according to their materials, over 800 technology suppliers and 600 integrators, creating the largest platform of its kind globally. This one-stop shop model provides immediate, curated access to specialists and pre-vetted solutions, greatly simplifying the sourcing and implementation process for clients. It's like having a dedicated expert directory and project manager built right into the platform. Of course, they also face competition from large tech players like Siemens, ABB, Schneider Electric, and others who have established market positions, deep pockets, and long-standing legacy relationships with many large manufacturers. DBR77, according to the sources, initially focused strategically on small and medium-sized enterprises, SMEs, a segment often overlooked or underserved by these major providers due to their smaller deal sizes and different needs. However, its flexible, simple, and notably lower-cost subscription model, compared to competitors' traditional large-scale deployments, which often cost hundreds of thousands or even millions of euros upfront, has also started attracting larger corporations. These larger players apparently value the easy entry point, the scalability, and the potential for faster ROI offered by DBR77's approach. It offers a lean, agile alternative to often cumbersome traditional enterprise solutions.
Right, so they cleverly carved out a crucial niche and then started expanding by proving a highly accessible and valuable proposition, even appealing to bigger fish. That's a smart competitive strategy.
Absolutely. Then there are the inevitable cloud data processing concerns, particularly around legal compliance and data security, like GDPR in Europe. Companies are rightly cautious about moving sensitive operational data to the cloud, fearing potential security breaches or failing to meet complex regulatory requirements. It's a major concern. DBR77 addresses this head-on by adhering to the highest security standards, being ISO 27001 certified. All client data is stored on secure AWS servers located in Frankfurt, Germany, specifically chosen to meet stringent EU GDPR requirements. It's highlighted as a strictly B2B platform, with all users, clients, suppliers, integrators signing mutual non-disclosure agreements, NDAs, ensuring protection for all sensitive operational and commercial information shared within the ecosystem. Data security and privacy seem baked into their core offering, not an afterthought. For companies looking at difficult international expansion, navigating diverse legal, tax, and technological standards across different countries is a significant hurdle. DBR77 actively collaborates with local system integrators and distributors in various regions. Many of their existing partners already operate internationally. This facilitates adaptation to specific local requirements, regulations, and market nuances, and helps accelerate expansion by leveraging established local expertise and relationships. They scale globally by acting locally through partners. Finally, there's the challenge of meeting high ROI requirements for clients, especially in tough economic times. Industrial clients need to see quick, clear, and substantial savings or performance improvements to justify the initial cost and, crucially, to continue their subscriptions long term. They need tangible proof of value, not just vague promises of future benefits. The low initial cost via the subscription model inherently contributes to a more rapid ROI calculation. Less upfront investment means payback happens faster. The integrated marketplace also helps clients choose optimal, cost-effective solutions quickly, shortening implementation times and increasing the likelihood of achieving fast, noticeable results that justify the continued investment. And to ensure they stay ahead and continue delivering value, there's the ongoing challenge of the continuous development of AI and digital twin technologies. The field moves incredibly fast. DBR77's strength here, reportedly, lies in its ability to collect massive amounts of both real operational data and synthetically generated data from simulations. This serves as an excellent, ever-growing training base for their AI algorithms, allowing them to continuously improve their predictive accuracy and analytical capabilities. Their direct collaboration with technology providers and integrators via the marketplace ensures they stay updated on the latest hardware innovations and new software solutions. Plus, DBR77's spatial analysis functionalities allow integration with the latest external AI models and tools, keeping the platform at the forefront of innovation and ensuring their solutions evolve as quickly as the challenges and technologies do.
Wow, okay. This truly shows that choosing the right technology partner isn't just about the list of features on a datasheet, is it? It's really about how well they anticipate and proactively solve the real-world obstacles you're likely to face during implementation and ongoing use. It's about finding a partner that genuinely smooths the path to digital transformation, helping you actually patch those leaks effectively, not just identify them and leave you to figure out the rest. So, okay, after all this discussion, understanding the problems, the critical role of data, the power of quick reactions, and the advanced technology that can help, what can you actually do? Starting tomorrow, maybe. What are the actionable steps, the sort of roadmap to start moving the needle on your OEE, even if you don't have a full DBR77 system or a sophisticated digital twin in place just yet? Where do you begin?
That's the critical question, isn't it? Because knowledge without action is just, well, trivia. It doesn't improve anything. Our sources provide a pretty clear step-by-step guide that, honestly, anyone can begin to implement, laying the groundwork for potentially significant improvements down the line. The foundational step, the absolute starting point, without which any meaningful OEE improvement is severely limited, is to implement some form of real-time data collection system, or as close to real-time as you can get initially. This means moving beyond relying solely on manual logs filled out at the end of a shift and messy clipboards, whether it's through installing simple, inexpensive sensors on critical machines, leveraging existing PLC data, or implementing a more advanced IoT system like DBR77's eventually. You need consistent, accurate, and timely data on machine status, running down idle, cycle times, and output counts. If you don't know what's happening the moment it happens, or at least very shortly after, you're always reacting way too late. You're seeing the water on the floor hours after the pipe burst. Once you're collecting that basic operational data, the next crucial step is to automate the recording of downtime causes as much as possible. It's not enough to just know a machine stopped. You absolutely need to know why it stopped, reliably and consistently. Moving beyond vague manual reason codes entered from memory or just guessed to precise automated tracking of why production stops. Whether it's a specific tool change procedure taking too long, a material jam consistently linked to a particular supplier's batch, or an unexpected fault code automatically logged from the machine's controller is crucial. This structured, accurate reason code data is what feeds your statistical analysis, like Pareto charts, and helps pinpoint those most frequent and impactful problems. It tells you precisely which pipe segment is leaking most often and why.
Right, right. So it's about getting granular with the why, getting automated where possible to remove human bias or forgetfulness, and getting that information in real time or close to it. That's the solid foundation for any real improvement strategy then.
Exactly, that's the bedrock. Then, building on that, you need to conduct daily indicator analysis and quick production meetings. Culture is key here. This fosters a culture of immediate data review and agile, problem-solving discussions right on the shop floor. Don't wait a week or a month to look at your OEE numbers and downtime reports in a management meeting. That's too late. Review the key indicators daily, perhaps at the start or end of each shift in a short, focused stand-up meeting. Ask simple questions. What were our biggest losses yesterday? What's the biggest drain on OEE right now on this line? What one thing can we do today to address the biggest issue? These quick data-driven meetings prevent small issues from festering and becoming accepted norms. They help catch those little leaks before they turn into floods. Following that, and this is really important for sustainability, you must train the team in OE data interpretation. Empower your people. Empower your operators, your maintenance techs, your shift leaders, and your managers to understand and act on the data they see. Make the data accessible and meaningful to them. If your team on the shop floor can interpret the basic OEE dashboards, understand what a rising micro-stop count actually means for their daily targets, or identify a trend in defect codes, they become an active part of the solution, not just passive recipients of top-down instructions. skills. This is where platforms with a human-centric design, like DBR77 is described, and their associated educational materials become incredibly valuable. They help democratize access to data insights and aim to turn every team member into a potential leak detector and repair person.
That makes so much sense. Yeah. If the data is only understood by a few engineers locked away behind a desk somewhere, it loses its power on the front lines, where the real action happens and the problems actually occur. Empowering the people closest to the machines is truly transformative, I'd imagine.
Precisely. Then strategically, you need to identify quick wins. Aim for some early successes. While long-term strategic improvements are obviously important, pinpointing and implementing rapid corrective actions that can yield immediate, tangible OEE improvements is vital for building momentum and belief. Sometimes it's a really simple adjustment to a machine setting suggested by the data, a minor process tweak based on a clear downtime pattern, or a quick training refresh for a particular shift struggling with a specific task. These quick wins build momentum, demonstrate the tangible value of collecting and analyzing the data, and motivate the entire team for further, potentially larger improvement efforts. They show that fixing those small leaks has an immediate positive effect and that change is possible. And finally, critically, create a continuous improvement plan based on data. OEE isn't a project with an end date. This means establishing a long-term systematic strategy for ongoing optimization, consistently driven by the insights emerging from your operational data. OEE improvement isn't a one-and-done project. It's an ongoing journey, a continuous cycle, like PDCA, Plan, Do, Check, Act. Use your data to identify the next biggest opportunity for improvement, implement a solution, maybe testing it in a digital twin first if you have one, measure its impact rigorously using the same data system, verify the improvement, standardize the change, and then iterate, find the next biggest opportunity. This cyclical, data-driven approach ensures sustained gains over the long term and helps prevent new leaks from forming or old ones from quietly reappearing. It builds a culture of continuous improvement.
Okay, fantastic. These aren't just theoretical concepts. They're genuinely practical steps you can start implementing today, or at least planning for tomorrow. They lay the groundwork for a more efficient, data-driven future for your operations. And sounds like even without a full-blown digital twin immediately, just starting with better real-time data collection, automated reason coding, and daily analysis meetings can make a huge difference in finding and fixing those hidden losses.
Absolutely. Ultimately, what does improving OEE truly mean for your business? We need to connect it back to the bottom line. How does it translate to your overall profitability and your strategic advantage in the marketplace? Because at the end of the day, all this technological sophistication and operational discipline needs to deliver tangible value where it counts most on the financial statements. The direct benefits to profitability, based on our sources and the examples, are quite profound, actually. First, and most obviously, you achieve increased output at the same or similar costs. This is fundamental. By optimizing your OEE, you're essentially getting more finished, saleable products out of your existing machinery, your current staff levels, and your existing facility footprint, all without proportionally increasing your operational expenses. This is pure efficiency gain translating directly into higher production volume potential, which means higher revenue potential without the corresponding increases in fixed or variable costs. Your margins improve. Second, you see reduced waste across the board, significantly reduced waste. A higher OED inherently means fewer defects being produced, less need for costly rework or scrapping of materials, and more efficient machine operation, less energy consumed per unit perhaps. This directly leads to lower material costs and lower energy losses. It cuts costs at multiple levels of your operation, making your processes leaner, more sustainable, and often more environmentally friendly as a byproduct. It's about doing more with less resource-wise. Third, you typically achieve faster fulfillment times for customer orders. Speed matters. When your production lines are running more smoothly, more predictably, and more efficiently, with fewer interruptions and faster changeovers, you naturally shorten the overall order realization times the time from order receipt to shipment. This means you can deliver products to your customers more quickly and reliably. This leads to greater customer satisfaction, improved loyalty, and can be a significant competitive advantage in the market. In today's fast-paced, on-demand world, speed and reliability often win business, sometimes even over pure cost. And finally, all these factors, higher output, lower costs, better quality, faster delivery, combine inevitably to deliver enhanced competitiveness and overall profitability. Overall, a higher OEE directly boosts a plant's market position and its fundamental financial health. It allows you to produce more at a lower unit cost with better, more consistent quality and faster, more reliable delivery times. That's a winning combination. This isn't just an operational metric buried in a report. It's a powerful strategic lever for long-term business success. It turns those hard-won efficiency gains into real financial growth and a stronger, more resilient standing in the market. It's about future-proofing your operations in what is often a highly competitive global landscape.
Yeah, it's clear. OEE isn't just another operational metric or another three-letter acronym to track. It's a truly powerful strategic lever for business success, turning those efficiency gains into real, tangible financial growth. It really is about getting the absolute most out of what you already have invested in, and then some, transforming those hidden losses into visible profits. Well, this deep dive has truly shown us, I think, that understanding OEE in detail, leveraging granular real-time data, and responding swiftly to the insights that data provides is nothing short of a game changer for modern industrial operations. It really feels like the difference between guessing in the dark and knowing exactly where to focus your efforts, between constantly reacting to problems and proactively optimizing for peak performance.
Indeed. And platforms like DBR77, as described in our sources, are clearly designed to empower this exact journey. They aim to transform that raw, often overwhelming data into decisive, intelligent action and yield tangible results that can fundamentally shift a company's efficiency and its competitive edge in the market. By integrating IoT for data capture, digital twin for simulation and prediction, AI for analysis and recommendations, and a robust marketplace for rapid solution implementation, they provide a comprehensive ecosystem to tackle these complex OEE challenges head-on, giving you the full toolkit, essentially, to find, simulate fixing, actually fix, and even prevent those costly leaks in your production system.
So maybe a final thought for everyone listening. Consider this. What hidden microstops or unrecorded downtimes or slightly slower than optimal cycles are silently eroding your productivity right now? Unseen and unaddressed, like those invisible trips in the system we talked about. And what could be truly unleashed, what potential capacity, what cost savings, what competitive advantage if you had the precise data and the right tools to instantly know their causes, to simulate their fixes risk-free, and to implement the best solutions rapidly, transforming those invisible losses into significant measurable gains, turning those frustrating drifts into, well, maybe floods of new efficiency and profit.
It's a profound question, really. It speaks directly to the often vast, untapped potential lying dormant within many industrial facilities today. And the opportunity to unlock that potential through the intelligent application of data and technology is, frankly, immense.
Absolutely. So if this deep dive has sparked your curiosity about transforming your own operations and unlocking greater efficiency, we definitely encourage you to continue exploring how comprehensive data solutions, whether it's DBR77 or other approaches, can illuminate and help you optimize your full potential. There's likely a world of efficiency just waiting to be discovered within your own walls. Thanks for joining us on the deep dive.